Alright guys, welcome to another video. Today we're going to be factoring quadratic trinomials, factoring standard form into factored form. So the warm-up for today is going to be removing the greatest common factor of this quadratic trinomial. Each one of these has a greatest common factor of 2. You might be tempted to say x because the x squared and the x, but 24 lacks an x, so we can't say the greatest common factor is x, but we can definitely say the greatest common factor is 2. So if I factor out the 2 here, okay, what's left, if I'm going to divide this by 2, I am left with x squared. If I divide 12x by 2, I'm left with 6x. And if I divide 24 by 2, I am left with 12. So you can double check your work by distributing, and you should end up with the original equation or the original expression. So here's your learning targets for today. We're learning how to factor a standard form quadratic equation into factored form because it's one of the most important concepts in Algebra 2. You can factor a quadratic equation like x squared plus 2x plus 1 into its two linear factors when you're successful. So, factoring a quadratic equation in standard form, okay? To factor an equation in the form x squared plus bx plus c plus find two integers r and s who are going to add up to b and who are going to multiply together to be c. So, remember, to factor, okay, we're breaking down the terms of the equation into its factors and writing them as such. So, this quadratic equation is going to result in two linear factors. So I'm going to make sure that we remember that we're going to get two linear factors out of this when we are done. So two linear factors, okay, a linear factor would look something like this. So a linear factor would be like saying x plus 1. So x plus 1 would be a linear factor. Or perhaps we might have a linear factor like x minus 2. So these are linear factors. So we're going to need two of them for a quadratic equation when we finish factoring it. So if we just ask ourselves, okay, what two numbers multiply to 6 but add to be 5, we're just going to have to guess and check until we get it right. So let's see if we can figure out how to keep track of that. So this is called the diamond method. I call it the Xbox method because we're making a big Xbox here. What we can do, okay, is we're going to take the coefficient of x, okay? The coefficient of x is just 1 for now, okay? You're going to multiply these two things together, the first and the last together, which for the one it's always 1 out front, okay, for the ones we're going to do right now, when it's 1 out front, you're always going to have that end coefficient of 10. And then the middle number goes down on the bottom. So what you're going to do is you're going to look for two numbers, okay, that multiply to be the top. So I'm looking for two numbers that multiply to be 10. Excuse my writing. So multiply to 10. But they need to add to 7. Okay, so I'm going to look for my factors of 10. If I list out my factors of 10, okay, factors of 10 that I can think of would be, I can think of 1 and 10. So 1 times 10 would get me 10. And I can think of 2 times 5. So if I just wrote them in two different formats. Oops. If I'm going to take a think about this really quick, I can easily determine that 2 times 5 will get me 10. Okay. And it will also 2 plus 5 add to 7. So 2x, 5x, and then I have what I need to write my linear pair. Okay, so the pair of linear factors. So what's going to happen then is you're going to have, okay, we're going to determine if each one is positive. Well, this is positive, positive. So x plus 2, that's going to be one of my factors. and the other one, so multiplied by another linear factor, x plus 5. So you can see how the 2 is used in x plus 2 and the 5 is used in x plus 5. So our final answer for factoring x squared plus 7x plus 10 is x squared times x squared, x plus 2 times x plus 5. So factor x squared plus 6x plus 9. So I'm going to draw a really big x. Doing the best that I can. I apologize, it's pretty tough with a computer mouse. So I know that 1 times 9, these are going to I need to find two factors that multiply to 9, and they are going to add up to 6. So I'm going to list out the factors of 9. So 1 times 9 is one set of factors, and 3 times 3. Okay, well, I can see that 3 plus 3 will equal 6. So there's the 2 that I'm looking for. So it's going to be this factor pair here. So I will then write out my solution as x plus 3 times x plus 3. And if I wanted to check it, if I wanted to check my answer, I could FOIL it. Okay, x times x is x squared. 3x times, or 3 times x is 3x, 3 times x is 3x, so I've got the 6x that I need, and 3 times 3 is 9, so that works out. So what happens when one of the numbers is negative? Okay, so here I throw a little monkey wrench into the plans. So I'm going to start by drawing my x. So 1 times negative 12, because remember there's a 1 out front here. So I need to think of two numbers that multiply to negative 12, and they add up to 1. Okay, so it helps me, okay, to know that the only way that I can make a negative number here is if one of the numbers is negative. So I'm going to just slot a negative over here, okay? One of my two factors is going to have to be negative. So now I'm going to think of factors of 12, okay? I'm just going to list them all out. I'm just going with 12, not negative 12. I'm just going to do the positive 12, and we'll come back to making it positive or negative in a bit. So I know 1 times 12. I know 2 times 6. And 3 times 4. Okay, so here's where our reasoning skills come into play. Okay, so if I do 1 and 12, if one of these is negative, okay, if I make 1 negative, 1 negative 1 plus 12, okay, would equal, so if I did negative 1 plus 12, so if I made one of them negative, I would get negative 11. Or I could do it the other way, and I could do 12 plus negative 1, and that gives me positive 11. Well, either way, that doesn't work out. So it doesn't add up to that 1 that I need in the middle. Okay, so I'll try it with the 2 and the 6. So if I do 2 times, if I do 1, or negative 2 is 2 as negative, and I add 6 to it, I'd get positive 4. If I did negative 6 plus 2, I get negative 4, which still doesn't work. So I'm hoping that in 3 and 4 I can find a pair that works. So if I do negative 3 plus 4, I get, so negative 3 plus 4 is positive 1. Ding ding, I have found my winner. So I have found the way to arrange, okay, the positive and negative one. So 4, and then this one would be negative 3. So my solution then, when I factor it, is going to be x plus 4, and then it's going to be x minus 3. Now, what's going to end up happening is over time, you're going to develop the ability to look through factors like this, okay, and instantly tell 11, 8, or 1 when you combine them, like -11, the 4, or the 1 when you add or subtract them. You'll just get really good at looking through factors and be able to tell which one is correct. So at some point, you won't have to do all this listing out, but you definitely should get in the habit of at least trying to go through this process until you get really, really fluent at it. And then it becomes more of a thinking game, less of a showing work game. So one more really difficult one here. Well, I shouldn't say it's really difficult, but it is if you don't know your factors off the top of your head. So I'm just going to draw my x. Okay, so 1 times 56 gives me the 56 that I'm looking for up at the top box, and I need to add up to 15. So factors of 56, 1 times 56, 2 times 28, 4 times 14, and 7 times 8. Oh, well, I think I found it because this adds up to 57, this adds up to 30, this adds up to 18, this adds up to 15. So we'll go with the 7 and the 8. And since the end is positive, both of these have to be positive. So then I just easily stumbled upon my solution of x plus 7 and then x plus 8. So that's my solution for that. All right, the next concept is called the zero product property. So the zero product property states that if A times B, so two quantities, multiplied together equals 0, then one of them, either A or B, has to be 0, or they're both 0. So if I have to solve the equation x minus 5, there's a multiplication symbol here, okay, times x minus 3 equals 0, the zero product property says that x minus 5 times x minus 3 equals 0, I can split it, okay? I split it into this statement, and I split it into this statement, because both of these statements must either be true or one is true at the same time. So either both are true at the same time or only one of them is true. But either way, you can still make the assumption and still say, hey, this is true, this is true. That allows me to do some quick algebra, okay, to find the solutions for this factored form. Why are we looking for 0? Because 0 is the special place, okay? 0, we find zeros with quadratic equations. So if I set an equation equal to 0, that is me solving the quadratic equation. So here's an example, okay? I have x minus 4 times x plus 12 equals 0. Well, according to the zero product property, the ZPP, this states that x minus 4 equals 0, or x plus 12 equals 0. So now, okay, I can solve the equations, and I solve them separately, okay? I'm going to solve them separately, so I'm just going to put up this imaginary line here. It's one or the other. You solve them differently. So I'm going to add 4 to both sides of this miniature equation. And by doing so, you get x equals 4. Or you're going to subtract 12 from both sides here. You would get x equals negative 12. So those are your two solutions. So that previous quadratic equation is what happens when one comes in factored form. Okay, this is not in factored form, this is in standard form, so we have to factor it first before we can apply the zero product property. So let's just factor it. Okay, we're going to go ahead and use the diamond, or the X, to do so. The top number is 12, and the bottom number is -7. Okay, so let's list out factors of 12. Well, we remember the factors of 12 from before. 1 and 12 was a pair of factors. 3 and 4 and 2 and 6. Okay, so if I did 1 plus 12, okay, I'd get 13. If I did 3 plus 4, I'd get 7. And if I did 2 plus 6, I'd get 8. Okay, none of those work because it's -7. But I think I'm onto something with the 3 and the 4. Now, this is positive on the end. Okay, so the ways I can make a positive number would be negative times negative, or positive times positive. If I did +3 times +4, I would get +12, but the middle number would be +7. If I did -3 times -4, okay, the end number would be that +12, but that middle number would be -7 when they're added together. So there's my solution. So I get x minus 3 times x minus 4 equals 0. So now here's where I'm going to break it apart with the zero product property. And when you do so, you make two statements. X minus 3 equals 0. Or you're going to say x minus 4 equals 0. So it's both of those. So there's my little line saying it's one or the other. And then they're solved differently. Okay, we're going to add 3 to both sides here. When you do so, x equals 3. And for this one, when you add 4 to both sides, you get x equals 4. So those are the two solutions of your quadratic trinomial. And that's going to be it for this one, guys. Thanks for watching. Best of luck on your homework.